everyone. Today, we are going to explore one of the most important topics in industrial electrical systems and automation. A topic that is used in almost every industrial machine, production line, packaging system, conveyor, CNC machine, industrial robot, and PLC system. That topic is sensors. But here is the important question. Why are some sensors two-wire devices? Why are some three-wire devices? What is the difference between four-wire and five-wire sensors? Can any sensor be connected to any PLC or relay? And most importantly, what problems can occur if the wrong type of sensor is selected? By the end of this lesson, you will be able to identify the operating principle and output type of a sensor simply by looking at the number of wires connected to it. What is a sensor? Before we go into the number of wires, let's first understand what a sensor actually does. The main function of a sensor is to detect a condition and send a signal. For example, detecting the presence of a metal object. Detecting the presence of a physical object. Detecting the position of a mechanism. Detecting whether a door is open or closed. Detecting liquid level. Detecting motion. But the important point is this. A sensor does not perform any action by itself. It only generates information. This information may be sent to a PLC, a relay, a contactor, an HMI, a controller, or an input module. Now we move to the first group, the two-wire sensors. These are the simplest type of industrial sensors. These sensors are available in both AC and DC models. They may also be manufactured as cable-type or connector-type sensors. How they work. A two-wire sensor is connected exactly like a switch in series with the load. In other words, it must always be connected in series with the load. The circuit path is as follows. Power supply. Load. Sensor. Return to power supply. What is leakage current? Now we come to the most important characteristic of two-wire sensors. Even when the sensor is off, a very small amount of current still flows through it. This current is called leakage current. The reason for this is the internal electronic circuitry of the sensor. Why leakage current can be a problem? In many loads, leakage current is not important. However, if the load is very sensitive, such as PLC inputs, electronic input cards, highly sensitive relays, this leakage current may cause unwanted operation. Sometimes, it can even be observed that a relay remains energized after the sensor has been switched off. Solution. To solve this problem, a resistor is connected in parallel with the load. This resistor carries the leakage current. As a result, the load is no longer affected by the leakage current. Advantages of two-wire sensors. Simple wiring. Fast installation. Suitable for replacing switches. Disadvantages of two-wire sensors. Presence of leakage current. Limitations when connected to some electronic inputs. Less flexibility compared to newer sensor models. To overcome the limitations of two-wire sensors, three-wire sensors were developed. Today, this is the most common type of industrial sensor used in factories. Standard wiring. In most well-known brands. Brown wire, positive supply. Blue wire, negative supply. Black wire, output. However, the manufacturer's datasheet should always be checked. Why are three-wire sensors more popular? In these sensors, the power supply is separated from the output circuit. As a result, the leakage current problem is almost eliminated. Connection to a PLC also becomes much easier. What is PNP? In a PNP sensor, when the sensor is activated, the positive voltage is supplied to the load. For this reason, it is also called a sourcing output. What is NPN? In an NPN sensor, when the sensor is activated, the output is connected to the negative side. For this reason, it is called a sinking output. Which one is better? From a functional point of view, both types work correctly. However, in many European countries and modern industrial systems, PNP sensors are more common. Many modern PLCs are also designed to work with PNP sensors. Advantages of 3-wire sensors. No leakage current problem. Easy connection to PLCs. High accuracy. Fast response. Long service life. Now we move to 4-wire sensors. Up to this point, every sensor had only one output. However, in some applications, we need both NO and NC outputs at the same time. What is NO? NO stands for normally open. In its normal state, the output is open. When the sensor is activated, the output closes. What is NC? NC stands for normally closed. In its normal state, the output is closed. When the sensor is activated, the output opens. The biggest advantage of a 4-wire sensor is that both outputs are available simultaneously. As a result, a single sensor can be used for multiple control circuits. Wire colors. Brown equals positive supply. Blue equals negative supply. Black equals NO output. White equals NC output. However, the manufacturer's datasheet should always be considered the primary reference. 5-wire sensors. Now we come to the most advanced group in this lesson, 5-wire sensors. The main difference is that these sensors typically use a relay output. Inside the sensor, there is a small relay. Because of this, the output behaves exactly like a mechanical contact. Terminals. 2 wires are used for the power supply. 3 wires are used for the relay output, including common, NO, NC. Major advantage. A relay output can switch different voltage levels. For example, 24 volts DC, 48 volts DC, 110 volts AC, 220 volts AC. However, the manufacturer's datasheet should always be consulted for the exact ratings and specifications. Relay output versus transistor output. Transistor output. Very fast operation. No switching noise. Very long service life. Relay output. Higher load handling capability. Greater flexibility. Can switch both AC and DC circuits. However, it operates more slowly. It produces an audible switching sound. And it has mechanical wear over time. Final comparison. If we want to summarize everything in a very simple way. 2-wire sensors. The simplest type. 3-wire sensors. The most widely used type in industry. 4-wire sensors. Provide both NO and NC output simultaneously. 5-wire sensors. Typically feature a relay output and are suitable for a wide variety of loads. Final summary. When you pick up a sensor, the number of wires is not just a physical characteristic. It provides very important information about the output type, the wiring method, the type of load that can be connected, compatibility with a PLC, operating speed, and its industrial applications. If you learn these concepts correctly, you will be able to make much more accurate and professional decisions when designing electrical panels, troubleshooting industrial machines, and programming PLC systems.